a WikiVidi Documentaries production. Don't forget to like and subscribe. Enjoy. Aviation safety. Aviation safety means the state of an aviation system or organization in which risks associated with aviation activities, related to, or in direct support of the operation of aircraft, are reduced and controlled to an acceptable level. Mentioned activities are encompassing the theory, practice, investigation, and categorization of flight failures, and the prevention of such failures through regulation, education, and training. It can also be applied in the context of campaigns that inform the public as to the safety of air travel. Typology. Runway safety represents percent of accidents, ground safety percent, and loss of control in flight percent. The main cause is pilot and command error. Safety has improved from better aircraft design process, engineering and maintenance, the evolution of navigation aids, and safety protocols and procedures. Transport comparisons. There are three main ways in which risk of fatality of a certain mode of travel can be measured: deaths per billion typical journeys taken, deaths per billion hours traveled, or deaths per billion kilometers traveled. The following table displays these statistics. For the United Kingdom, 1990, 2000. Note that aviation safety does not include the transportation to the airport. The first two statistics are computed for typical travels for respective forms of transport, so they cannot be used directly to compare risks related to different forms of transport in a particular travel, from A to B. For example, according to statistics, a typical flight from Los Angeles to New York will carry a larger risk factor than a typical car travel from home to office. But a car travel from Los Angeles to New York would not be typical. It would be as large as several dozens of typical car travels, and associated risk will be larger as well. Because the journey would take a much longer time, the overall risk associated by making this journey by car will be higher than making the same journey by air, even if each individual hour of car travel can be less risky than an hour of flight. It is therefore important to use each statistic in a proper context. When it comes to a question about risks associated with a particular long-range travel from one city to another, the most suitable statistic is the third one, thus giving a reason to name air travel as the safest form of long-range transportation. However, if the availability of an air option makes an otherwise inconvenient journey possible, then this argument loses some of its force. Aviation industry insurers base their calculations on the deaths per journey statistic, while the aviation industry itself generally uses the deaths per kilometer statistic in press releases. Since 1997, the number of fatal air accidents has been no more than 1 for every 2 billion person miles flown, and thus one of the safest modes of transportation when measured by distance traveled. United States. Between 1990 and 2006, there were 1,441 commuter and air taxi crashes in the U.S., of which 373 were fatal, resulting in 1,063 deaths. A disproportionate number of all U.S. aircraft crashes occur in Alaska, largely as a result of severe weather conditions. Alaska accounted for 513 of the total U.S. crashes. The number of deaths per passenger mile on commercial airlines in the United States between 2000 and 2010 was about 0.2 deaths per 10 billion passenger miles. For driving, the rate was 150 per 10 billion vehicle miles. For 2000, 750 times higher per mile than for flying in a commercial airplane. There were no fatalities on large scheduled commercial airlines in the United States in 2015 for the 6th year running. Security. Another aspect of safety is protection from attack, currently known as security and intentional causes of harm or property damage. The terrorist attacks of 2001 are not counted as accidents. However, even if they were counted as accidents, they would have added about 2 deaths per 2 billion person miles. 2 months later, American Airlines Flight 587 crashed in New York City, killing 256 people, including 5 on the ground, causing 2001 to show a very high fatality rate. Even so, the rate that year, including the attacks, is safe compared to some other forms of transport when measured by distance traveled. Before World War II. The first aircraft's electrical or electronic device avionics system was Lawrence Sperry's autopilot, demonstrated in June 1914. The Transcontinental Airway System chain of beacons was built by the Commerce Department in 1923 to guide airmail flights. Gyrocopters were developed by Wanda Lassieva to avoid stall and spin accidents, and for that invented cyclic and collective controls used by helicopters. It first flew on the 17th of January 1923. During the 1920s, the first laws were passed in the USA to regulate civil aviation, notably the Air Commerce Act of 1926, which required pilots and aircraft to be examined and licensed, for accidents to be properly investigated, and for the establishment of safety rules and navigation aids, under the Aeronautics branch of the United States Department of Commerce. One of the first air navigation to be introduced in the USA in the late 1920s was airfield lighting to assist pilots to make landings in poor weather or after dark. The Precision Approach Path Indicator was developed from this in the 1930s, indicating to the pilot the angle of descent to the airfield. This later became adopted internationally through the standards of the International Civil Aviation Organization. Jimmy Doolittle developed instrument rating and made his first blind flight in September 1929. The March 1931 wooden wing failure of a transcontinental and Western Air Fokker F-10 carrying Knute Rockne, coach of the University of Notre Dame's football team, comforted all metal airframes and led to a more formal accident investigation system. On September 4, 1933, a Douglas DC-1 test flight was conducted with one of the two engines shut down during the takeoff run, climbed to 8,000 feet, and completed its flight, proving twin aircraft engine safety. With great range than lights and weather immunity, radio navigation aids were first used in the 1930s, like the Australian radio stations guiding transport flights, with a light beacon and a modified Lorentz beam transmitter. The German blind landing equipment preceding the modern instrument landing system. ILS was first used by a scheduled flight to make a landing in a snowstorm at Pittsburgh, Pennsylvania, in 1938, and a form of ILS was adopted by the ICAO for international use in 1949. World War II and after. Hard runways were built worldwide for World War II to avoid waves and floating hazards plaguing seaplanes. Developed by the US and introduced during World War II, the Loran replaced the sailor's less reliable compass and celestial navigation over water and survived until it was replaced by the Global Positioning System. Following the development of radar in World War II, it was deployed as a landing aid for civil aviation in the form of ground-controlled approach systems, then as the airport surveillance radar as an aid to air traffic control in the 1950s. A number of ground-based weather radar systems can detect areas of severe turbulence. A modern Honeywell IntuView weather system visualizes weather patterns up to 300 miles away. Distance measuring equipment in 1948, and VHF omnidirectional range stations became the main route navigation means during the 1960s, superseding the low-frequency radio ranges and the non-directional beacon. The ground-based VOR stations were often co-located with DME transmitters, and the pilots could establish their bearing and distance to the station. With the arrival of Wide Area Augmentation System, satellite navigation has become accurate enough for altitude as well as positioning use, and is being used increasingly for instrument approaches as well as en route navigation. However, because the GPS constellation is a single point of failure, onboard inertial navigation system or ground-based navigation aids are still required for backup. Rockwell Collins reports it costs more to certify than to develop a system, from 75% engineering and 25% certification in past years. It calls for a global harmonization between certifying authorities to avoid redundant engineering and certification tests rather than recognizing the other's approval and validation. Future. In June 2014, the International Air Transport Association said it was working on implementing new measures to track aircraft in flight in real time. A special panel was considering a range of options, including the production of equipment especially designed to ensure real-time tracking, since pilot error accounts for between 1/3 and 60% of aviation accidents. Advances in automation and technology could replace the aircraft pilots after eliminating the flight engineer, but in complex situations, With severely degraded systems, the problem-solving and judgment capability of humans seems difficult to achieve by automated systems, like the United Airlines Flight 232 or Qantas Flight 32. While the accident rate is very low, to ensure they do not rise with the air transport growth, learning from consequence-less incidents should develop through blame-free atmosphere and information sharing. For better reporting. Foreign object debris. Foreign object debris includes items left in the aircraft structure during manufacture/repairs, debris on the runway, and solids encountered in flight. Such items can damage engines and other parts of the aircraft. Air France Flight 4590 crashed after hitting a part that had fallen from another aircraft. Misleading information and lack of information. A pilot misinformed by a printed document, reacting to a faulty instrument or indicator, or following inaccurate instructions or information from flight or ground control can lose spatial orientation, or make another mistake, and consequently lead to accidents or near misses. Lightning. Boeing studies showed that airliners are struck by lightning twice per year on average. Aircraft withstand typical lightning strikes without damage. The dangers of more powerful positive lightning were not understood until the destruction of a glider in 1999. It has since been suggested that positive lightning might have caused the crash of Pan Am Flight 214 in 1963. At that time, aircraft were not designed to withstand such strikes, because their existence was unknown. The 1985 standard in force in the US at the time of the glider crash, Advisory Circular AC 2053A, was replaced by Advisory Circular AC 2053B in 2006. However, it is unclear whether adequate protection against positive lightning was incorporated. The effects of typical lightning on traditional metal-covered aircraft are well understood, and serious damage from a lightning strike on an airplane is rare. The Boeing 787 Dreamliner, of which the exterior is carbon fiber reinforced polymer, received no damage from a lightning strike during testing. Ice and snow. Ice and snow can be major factors in airline accidents. In 2005, Southwest Airlines Flight 1248 slid off the end of a runway after landing in heavy snow conditions, killing one child on the ground. Even a small amount of icing or coarse frost can greatly impair the ability of a wing to develop adequate lift, which is why regulations prohibit ice, snow or even frost on the wings or tail prior to takeoff. Air Florida Flight 90 crashed on takeoff in 1982 as a result of ice/snow on its wings. An accumulation of ice during flight can be catastrophic, as evidenced by the loss of control and subsequent crashes of American Eagle Flight 4184 in 1994, and Comair Flight 3272 in 1997. Both aircraft were turboprop airliners, with straight wings, which tend to be more susceptible to in-flight ice accumulation than are swept-wing jet airliners. Airlines and airports ensure that aircraft are properly de-iced before takeoff whenever the weather involves icing conditions. Modern airliners are designed to prevent ice buildup on wings, engines, and tails by either routing heated air from jet engines through the leading edges of the wing and inlets, or on slower aircraft, by use of inflatable rubber boots that expand to break off any accumulated ice. Airline flight plans require airline dispatch offices to monitor the progress of weather along the routes of their flights, helping the pilots to avoid the worst of in-flight icing conditions. Aircraft can also be equipped with an ice detector in order to warn pilots to leave unexpected ice accumulation areas before the situation becomes critical. Pitot tubes in modern airplanes and helicopters have been provided with the function of pitot heating, to prevent accidents like Air France Flight 447 caused by the pitot tube freezing and giving false readings. Engine failure. An engine may fail to function because of fuel starvation, fuel exhaustion, foreign object damage, mechanical failure due to metal fatigue, mechanical failure due to improper maintenance, mechanical failure caused by an original manufacturing defect in the engine, and pilot error. In a multi-engine aircraft, failure of a single engine usually results in a precautionary landing being performed, for example landing at a diversion airport instead of continuing to the intended destination. failure of a second engine or damage to other aircraft systems caused by an uncontained engine failure may, if an emergency landing is not possible, result in the aircraft crashing. Structural failure of the aircraft. Examples of failure of aircraft structures caused by metal fatigue include the de Havilland Comet accidents and Aloha Airlines Flight 243. Now that the subject is better understood, rigorous inspection and non-destructive testing procedures are in place. Composite materials consist of layers of fibers embedded in a resin matrix. In some cases, especially when subjected to cyclic stress, the layers of the material separate from each other and lose strength. As the failure develops inside the material, nothing is shown on the surface. Instrument methods have to be used to detect such a material failure. In the 1940s, several Yakovlev Yak-9s experienced delamination of plywood in their construction. Stalling. Stalling an aircraft is dangerous and can result in a crash if the pilot fails to make a timely correction. Devices to warn the pilot when the aircraft's speed is decreasing close to the stall speed include stall warning horns, stick shakers, and voice warnings. Most stalls are a result of the pilot allowing the airspeed to be too slow for the particular weight and configuration at the time. Stall speed is higher when ice or frost has attached to the wings and/or tail stabilizer. The more severe the icing, the higher the stall speed. Not only because smooth airflow over the wings becomes increasingly more difficult, but also because of the added weight of the accumulated ice. Crashes caused by a full stall of the airfoils include fire. Safety regulations control aircraft materials and the requirements for automated fire safety systems. Usually these requirements take the form of required tests. The tests measure flammability of materials and toxicity of smoke. When the tests fail, it is on a prototype in an engineering laboratory rather than in an aircraft. Fire and its toxic smoke have been the cause of accidents. An electrical fire on Air Canada Flight 797 in 1983 caused the deaths of 23 of the 46 passengers, resulting in the introduction of floor-level lighting to assist people to evacuate a smoke-filled aircraft. In 1985, a fire on the runway caused the loss of 55 lives, 48 from the effects of incapacitating and subsequently lethal toxic gas and smoke in the British Air Tours Flight 28M accident, which raised serious concerns relating to survivability, something that had not been studied in such detail. The swift incursion of the fire into the fuselage and the layout of the aircraft impaired passengers' ability to evacuate, with areas such as the forward galley area becoming a bottleneck for escaping passengers, with some dying very close to the exits. Much research into evacuation and cabin and seating layouts was carried out at Cranfield Institute to try to measure what makes a good evacuation route, which led to the seat layout by overwing exits being changed by mandate and the examination of evacuation requirements relating to the design of galley areas. The use of smoke hoods or misting systems were also examined, although both were rejected. South African Airways Flight 295 was lost in the Indian Ocean in 1987 after an in-flight fire in the cargo hold could not be suppressed by the crew. The cargo holds of most airliners are now equipped with automated halon fire extinguishing systems to combat a fire that might occur in the baggage holds. In May 1996, ValueJet Flight 592 crashed into the Florida Everglades a few minutes after takeoff because of a fire in the forward cargo hold. All 110 people on board were killed. At one time, firefighting foam paths were laid down before an emergency landing, but the practice was considered only marginally effective, and concerns about the depletion of firefighting capability due to pre-foaming led the United States FAA to withdraw its recommendation in 1987. One possible cause of fires in airplanes is wiring problems that involve intermittent faults, such as wires with breached insulation touching each other, having water dripping on them, or short circuits. These are difficult to detect once the aircraft is on the ground. However, there are methods, such as spread-spectrum time-domain reflectometry, that can feasibly test live wires on aircraft during flight. Brought to you by WikiVidi Documentaries. Would you like to know more?